Look up. Above you stretches the same sky that has fascinated every human being since the dawn of time. It's the great cosmic canvas, filled with points of light scattered like diamonds across an endless black sea. But among those countless stars, one faint milky band crosses the heavens, glowing softly, as if painted by the hand of eternity. That pale ribbon of light is our home, the Milky Way. From here on Earth it looks fragile, like a faint cloud brushed across the sky. But that gentle shimmer is something vast beyond imagination. It is not a cloud at all, but billions of stars, each one a sun, burning in the dark. When you look at it, you are looking from within the disk of our own galaxy. We are inside the spiral, seeing it edge on, like an ant trying to understand the shape of the forest from the ground. The Milky Way is enormous, so large that light itself, traveling at 300,000 kilometers every second, would take around 100,000 years to cross from one side to the other. Think about that. 100,000 years of light moving non-stop, and only then reaching the other edge. Every star, every world, every nebula, every trace of cosmic dust within that disk is part of this single galactic family, our family. But tonight we don't measure it in kilometers or light years. We measure it in feelings, in awe, in wonder, in quiet thought. Imagine standing on a dark hill far from the noise of the city. The night is still. The air is cool. Above you the Milky Way arches from horizon to horizon, glowing softly in the darkness. It looks alive. You feel its presence like a silent heartbeat pulsing across the universe. You lift your gaze, and for a moment time stops. That faint light has traveled for tens of thousands of years just to reach you. Some of those photons began their journey when the first humans were learning to speak. You're not just looking into space, you're looking into the past. Every star in your view is a story from another time. Our sun is just one of these countless stars. It sits quietly in one of the Milky Way's smaller spiral arms, the Orion arm, tucked between the larger Sagittarius and Perseus arms. The sun, along with the Earth and every other planet we know, travels around the galactic center once every 230 million years. That means since the dinosaurs roamed the Earth, our planet has only gone around the galaxy a single time. A single orbit. To us, that's eternity. To the galaxy, it's just one heartbeat. The ancients saw that milky band and gave it names drawn from wonder. To the Greeks, it was the spilled milk of the goddess Hera, hence Milky Way. The Romans saw it as a divine road across the heavens. In China, it was the Silver River, separating two celestial lovers who could only meet once a year when magpies formed a bridge across the sky. The Mayans saw it as a world tree, stretching from the underworld to the heavens, connecting all realms of existence. No matter where humans lived, they looked up at the same band of light and felt the same pull, a sense that we were part of something vast and eternal. Now imagine rising above the clouds. You float upward higher and higher until the atmosphere fades into black, the stars sharpen. The earth below becomes a glowing blue marble, fragile and breathtaking. You are no longer bound by gravity. You are free. Ahead the Milky Way unfolds, a river of light flowing endlessly through space. From this new vantage, you see the truth. That faint band is the disk of a spiral galaxy. If you could rise millions of light years farther out, you would see it in all its glory, a glowing spiral with vast arms curling around a bright central core. Each arm contains billions of stars, swirling slowly through space, held together by gravity and time. The galaxy turns like a great wheel of light, taking hundreds of millions of years to complete a single rotation. Our entire solar system, every memory, every civilization, every dream ever dreamed is a single tiny grain in that vast structure. And yet we belong to it. Every atom in your body, every particle that makes you who you are, was born in the hearts of ancient stars within this very galaxy. Long ago, those stars lived, burned, and died, scattering their elements into space. Out of their ashes, new stars and planets were born, including our sun and Earth. You are quite literally made of the Milky Way. You are its child. As you drift in the quiet of space, you begin to notice the galaxy's rhythm. It is not silent, not really. It hums softly in the background of creation. The slow swirl of stars, the faint glow of nebulae, the invisible pull of dark matter, it all moves together, like a great cosmic symphony playing in the key of eternity. You see great clouds of dust stretching across the galactic plain. Within those clouds, new stars are forming, baby suns igniting for the first time. Each spark of light marks a new beginning, a new story waiting to unfold. Elsewhere, ancient stars are dying, collapsing, exploding, or fading into dim embers. Life, death, rebirth. The Milky Way breathes in endless cycles, creating and destroying, renewing itself over and over again. Now, imagine yourself drifting even farther out until you can see the entire galaxy as one glowing spiral floating in darkness. The arms sweep outward in elegant curves, each dotted with clusters of stars and pockets of gas. The core glows golden, dense with old suns and ancient energy. Around the edges, the light fades into the vast emptiness between galaxies. It's beautiful beyond words, a cosmic flower blooming in infinite night. From this distance, our entire existence, Earth, the moon, the sun, everything you've ever known is smaller than a grain of dust. Yet even here, there's no sense of loneliness, only wonder, only peace, because the Milky Way itself is alive, not in the way we are, but in the slow, majestic rhythm of creation. You realize something profound. Every star you see in the night sky belongs to this one galaxy. The constellations, the twinkling points we give names to, they are all neighbors in our Milky Way. The Andromeda Galaxy, which you might see faintly on a dark night, is one of the few visible beyond it, another island of stars, millions of light years away. But everything else your eyes can see, every shining dot, is home. And now, as you float above the Milky Way, you can feel its gravity not as a pull of force, but as a sense of belonging. You are part of this grand design. The light of the galaxy has flowed through you since before you were born. The same atoms that sparkle in distant stars now live within you. The universe is not out there, it's within you. You are the cosmos, thinking and dreaming about itself. The thought brings a kind of peace, a stillness. The realization that despite the vastness, despite the incomprehensible size, you are not insignificant. You are essential. For without beings like you, beings who can look up and wonder and ask, the universe would never know it exists. You are its eyes. You are its witness. The night grows quieter now. The stars drift past slowly. You take one more look at the glowing spiral of the Milky Way, your galactic home, and feel gratitude. Gratitude for being alive in this small corner of infinity, for having the chance to see, to think, to dream. In this stillness, you understand. The Milky Way is not just out there. It's within every breath, every heartbeat, every atom. The light of its stars fills your blood. Its dust is your bones. You are a child of starlight, so breathe deeply. Let that thought settle in your mind. The galaxy turns, the stars shine, the night whispers. You are home, the Milky Way. The name sounds gentle, like something you could reach out and touch. But what is it really? What lies behind that soft, glowing band that stretches across the night sky? When we speak of the Milky Way, we are speaking of a galaxy, a vast collection of stars, dust, gas, and dark matter, all bound together by gravity. It is not a single object, but a cosmic city made of hundreds of billions of suns, each with its own planets, moons, and mysteries. A galaxy is more than a gathering of stars. It is an ecosystem of creation. Within it, stars are born, live their long lives, and die, enriching the space around them with the raw materials for new generations. Gas clouds collapse under their own weight, igniting into brilliance. Supernovae erupt like fireworks, scattering elements across the void. Dust collects and drifts, forming the building blocks of future worlds. It is a cycle that has been repeating for billions of years, shaping not only the Milky Way, but everything that exists within it, including us. The Milky Way itself is shaped like a spiral. Imagine a great, luminous whirlpool turning slowly in space, its arms curling gracefully outward from a glowing center. Each arm is a river of stars, gas, and dust, winding through the galaxy like the brushstrokes of a cosmic artist. The arms are where new stars are born, places filled with nebulae, glowing clouds of gas, illuminated by newborn suns. Between these arms are quieter regions, older, more settled, filled with ancient stars that have burned steadily for billions of years. At the center of it all lies a dense, mysterious region called the galactic core, a bright hub filled with tightly packed stars and energy. Deep within that core, hidden behind veils of dust, is something extraordinary, a supermassive black hole known as Sagittarius A. It contains the mass of millions of suns, pulling everything nearby into its gravitational embrace. Though invisible, its presence shapes the entire galaxy, influencing the motion of stars even tens of thousands of light years away. The Milky Way's disk, the thin, flat plane where most of its stars lie, stretches about 100,000 light-years across. It's astonishingly thin compared to its width, like a glowing coin floating in the dark. Yet within that disk, life thrives on a tiny planet orbiting an unremarkable star. Our sun sits roughly halfway from the center to the edge, in a quiet neighborhood, far from the chaos of the core but close enough to feel the galaxy's heartbeat. Surrounding this disk is the galactic halo, an immense spherical region filled with ancient stars, globular clusters, and invisible dark matter. It extends far beyond what we can see. The halo is like a ghostly shell holding the galaxy together. Though it emits little light, it contains most of the Milky Way's mass, an unseen skeleton of gravity that keeps the stars from flying apart. We cannot see dark matter, yet its influence is everywhere, a silent architect shaping the galaxy's fate. For most of human history, people believed the Milky Way was the entire universe. When our ancestors looked up, they thought everything that existed was contained within that glowing band. It wasn't until the 20th century that we learned the truth, that the Milky Way is just one among billions of galaxies scattered across the cosmos. The revelation changed everything. We realized that our home, magnificent as it is just one island in an endless cosmic ocean. But even within this one galaxy, there are mysteries enough to fill lifetimes. There are over 400 billion stars here, perhaps more. Around many of them orbit planets, moons, and systems beyond counting. Somewhere among them, there may be other worlds with oceans, skies, and perhaps even life. Each star you see in the night sky is a potential sun to another world, each one carrying stories we have yet to discover. Astronomers have spent centuries trying to understand the structure of our galaxy. It wasn't easy, because we live inside the Milky Way's disk, surrounded by its stars and clouds. It's like trying to map a forest while standing among the trees. For a long time, no one knew what shape it truly had. But through patience, measurement, and imagination, we began to piece it together. Using radio waves, infrared light, and other invisible forms of radiation, scientists were able to see through the dusty clouds that block visible light. They traced the spiral arms, mapped the locations of star clusters, and measured the motions of stars as they orbited the galactic center. Slowly, the picture came into focus. A barred spiral galaxy, with a central bar of stars stretching across the core and elegant arms sweeping outward in a grand rotation. It was a moment of revelation. Humanity finally saw the shape of its own home in the universe. The Milky Way, once just a streak of light across the sky, became a real, tangible thing, a structure we could measure, model, and understand. Yet, even with all our technology, there are still things we cannot see. Beyond the stars and the gas lies the dark matter halo, invisible but immense, and perhaps even dark energy beyond that, pulling the universe apart. The Milky Way is both known and unknown, a balance between what we can measure and what we can only imagine. And so, when you look up at the night sky, remember this: you are not just looking at stars. You are looking at the edge of a vast, rotating system, a living, breathing galaxy that has existed for more than 13 billion years. Its arms have turned countless times since the dawn of creation. Stars have been born and died, elements have been forged and scattered, and yet the galaxy endures, ever-changing, ever-beautiful. Somewhere in its quiet outskirts, our small blue world turns around an ordinary sun. And on that world, beings made of stardust lift their eyes and wonder what it all means. They give names to the stars, build telescopes to see farther, and dream of someday crossing the distances between them. In doing so, they become part of the Milky Way's story, the part of the galaxy that has learned to look back at itself and ask, "What am I?" The answer is simple yet profound. You are the galaxy thinking. You are the Milky Way made conscious. Every atom in your body was once part of a star that lived and died in this very system. You carry its memory. Its fire burns in your blood. When you breathe, when you dream, when you gaze at the stars, the Milky Way is gazing through you. And so the next time you see that faint band of light across the sky, know this. It is not something distant, not something separate. It is you. It is home. For as long as we've looked to the stars, one question has quietly challenged us. How can we measure something we live inside of? It's easy to look outward to see the moon, the planets, even other galaxies glowing faintly beyond our reach. But the Milky Way, that's different. We are within it, surrounded by its stars, dust, and clouds. Trying to map the galaxy from the inside is like standing in the middle of a vast forest and trying to sketch the shape of every tree. Everywhere we look, there is light, but also shadow, dust, and distance that distort our view. And yet, humans are patient observers. We learn not just by what we see, but by what we can infer by light, by motion, by time. To measure the Milky Way, astronomers had to learn to see in new ways. It began with something simple, the idea of parallax. Hold out your finger and close one eye, then switch to the other. See how your finger seems to shift against the background. That tiny movement is parallax, a change in perspective. Astronomers use the same principle to measure nearby stars. As the Earth moves around the Sun, a star's position seems to wobble slightly against the distant background. By measuring that angle, we can calculate its distance. It's a small effect, barely a whisper of motion, but it opened a window into the true depth of space. For centuries, we could only measure the closest stars just a few light years away. But as technology grew, so did our reach. We learned to use radio waves, infrared light, and later, space telescopes that could peer through the dust hiding the galaxy's heart. Each new wavelength revealed something different. Radio waves could pass through the clouds that block visible light, tracing the faint glow of hydrogen, the most abundant element in the universe. Infrared telescopes showed us the hidden stars buried deep within the galactic core. X-rays revealed the violent births and deaths of massive suns. Together, these eyes on the cosmos began to unveil the Milky Way's structure, its spiral arms, its dense center, its hidden halo. We could finally see the great wheel we had always been part of. The story of how we mapped the galaxy is one of patience and imagination. In the 18th century, the astronomer William Herschel and his sister Caroline began a bold attempt to chart the stars. They counted thousands of them, trying to determine the shape of the universe. Their drawing was crude but profound, an island of stars, wider than it was tall, with the sun somewhere near the center. They didn't yet know the scale or that other galaxies existed beyond ours, but they were the first to sketch the Milky Way as something more than a streak of light. Decades later, new instruments and photographic plates allowed astronomers to see deeper. They noticed that stars are not spread evenly. They cluster, thick in the center, sparse at the edges. By the 20th century, with radio telescopes and spectral analysis, we began to trace the spiral arms. Scientists discovered that the sun is not at the center, but halfway out along one arm, the Orion arm, orbiting a bright, massive core. Our perspective shifted. We realized we were not the center of the galaxy, merely a small part of a vast and balanced whole. Then came a new era, the age of space observatories. The Gaia mission, launched by the European Space Agency, became one of humanity's most ambitious attempts to map the Milky Way. Orbiting high above Earth, free from atmospheric distortion, Gaia measures the positions, brightness, and motions of over 1 billion stars. Each star's subtle movement, each flicker of light, contributes to a three-dimensional map, a living model of the galaxy in motion. With Gaia's data, we can now watch the Milky Way breathe. We see stars orbiting the core, clusters drifting apart, streams of stars from long-gone galaxies merging into ours. It's like watching the heartbeat of a cosmic organism. But even with all our technology, the Milky Way still hides secrets. Much of it is invisible, the dark matter that forms its skeleton, the cold gas clouds that cradle unborn stars, the regions too distant for our instruments to reach. Each discovery answers one question, but opens 10 more. It's as though the galaxy invites us to keep looking, always just beyond our grasp. And maybe that's the beauty of it. We are part of something so vast that even after centuries of observation, it still feels mysterious. We measure the unmeasurable not to conquer it, but to understand where we belong within it. Imagine, for a moment, drifting through the Milky Way not as a traveler but as an observer outside time. You'd see spiral arms glowing with newborn stars, clouds of gas swirling like brushstrokes of light, and entire clusters orbiting silently around the galactic core. The motion would be slow, majestic, and eternal, a kind of cosmic dance. Every rotation of the galaxy takes hundreds of millions of years. In that time, stars are born, civilizations rise and fall, and worlds come and go, yet the Milky Way continues, turning in a rhythm older than life itself. When you think of it like that, our attempts to measure it become something deeper than science. They are acts of connection, our way of reaching across the darkness to understand the structure of our home. Every telescope, every photograph, every calculation is a form of curiosity made visible, the galaxy learning to see itself through the eyes of its children. And so, when you look up at the faint, milky band of light tonight, remember, you are standing inside one of the greatest structures in the universe. You are surrounded by stars stretching in every direction, a glowing disk so large it takes light 100,000 years to cross it. The Milky Way is not just above you. It is around you, within you, and it is still unfolding its secrets, one photon at a time. When you look up at the night sky, the Milky Way seems like a flat river of light, simple, serene, and endless. But beneath that calm appearance lies a structure of incredible complexity and beauty. The Milky Way is not just a disk of stars. It is a living sculpture of motion, gravity, and time. Imagine it as a grand spiral, a cosmic pinwheel turning slowly in the dark. Its arms stretch outward from a brilliant core, curving gracefully through the void. From far away, it would look almost delicate, a swirl of starlight and dust, shimmering with blues, whites, and golden hues. Each arm is filled with billions of suns, glowing clusters, and nebulae, the cradles of newborn stars. But our galaxy is not perfectly symmetrical. It is slightly warped, twisted at the edges like a vast celestial wave. One side of the disk bends upward, the other downward, a gentle, mysterious distortion that ripples across hundreds of thousands of light years. Scientists believe this warp is caused by unseen forces, perhaps the pull of satellite galaxies that orbit us, or the influence of dark matter bending the galactic plane. Whatever the reason, it reminds us that the Milky Way is not static. It moves, flexes, and breathes, shaped by invisible hands. At its heart lies the galactic bulge, a glowing sphere of densely packed stars. This central region is ancient, filled with suns that have burned for billions of years. It shines golden, rich with heavy elements forged in the fires of countless generations of stars. Deep within this bulge, hidden behind veils of interstellar dust, sits the supermassive black hole, Sagittarius A. It is the silent anchor of our galaxy, its gravity binding everything together. Around it, stars orbit at breathtaking speeds, tracing paths curved by an invisible force. Extending from the bulge is the galactic disk, thin and wide, where most of the Milky Way's stars reside. This is the part we see when we look up, the luminous band of the night sky. The disk itself is divided into layers, the thin disk and the thick disk. The thin disk is where our sun lives, about halfway between the center and the edge. It's home to the youngest stars, brilliant and blue, still wrapped in clouds of gas and dust. Here, new suns are born in glowing nebulae, vast nurseries of hydrogen where gravity slowly draws matter together until fusion ignites. Between these clouds are older, settled stars, planets, and open clusters drifting in slow, steady orbits. The thick disk, on the other hand, lies above and below this plane, a more ancient population of stars, dimmer and redder, relics from an earlier time in the galaxy's history. Their orbits are tilted, less orderly, as if they carry the memory of collisions long ago, when smaller galaxies merged into ours, stirring the stars into a more chaotic motion. Each layer tells a different chapter of the Milky Way's story, the thin disk alive with youth, the thick disk echoing with the memory of its formation. Surrounding all of this is the galactic halo, an invisible sphere that extends far beyond the shining disk. It's made not only of ancient, wandering stars, but also of globular clusters, tight swarms of hundreds of thousands of stars orbiting together like glowing jewels in the dark. These clusters are some of the oldest things in existence, remnants from the galaxy's earliest days. And beyond even them lies the dark matter halo, vast, invisible, and all-encompassing. We cannot see it, yet it outweighs everything else in the galaxy combined. It is the unseen web of gravity that gives the Milky Way its structure, the hidden skeleton upon which the visible stars are draped. The entire galaxy moves as one great organism. Every star, every cluster, every cloud is part of an immense cosmic ballet. Our sun orbits the galactic center at a speed of over 800,000 kilometers per hour, completing one revolution roughly every 230 million years. That means since the dinosaurs roamed the Earth, our solar system has made just one full trip around the galaxy. We are travelers on an endless voyage through the stars. And yet, even as it moves, the Milky Way's shape remains stable, balanced by the pull of gravity and the momentum of rotation. Stars nearer the core orbit faster, drawn by the dense mass within. Those farther out move slower, their paths stretched wide. But something strange happens. The outer stars move faster than they should, as if held by an unseen hand. This was one of the first clues to the existence of dark matter, a hidden substance that extends beyond the galaxy's visible edge, shaping its motion and keeping it from flying apart. So the Milky Way is not just a disk. It is a layered, dynamic masterpiece. A luminous core, wrapped in spiraling arms, surrounded by a faint halo of ancient light. Its edges twist gently, its stars pulse and drift, and through it all, gravity sculpts every curve, every motion, every breath. If you could see it from far away, from millions of light years out in the cosmic deep, you would witness something breathtaking. A glowing spiral with a bright heart, its arms reaching gracefully into the dark, its faint halo shimmering like mist. You would see the stars of the thin disk glowing like a cosmic ocean, rippling with waves of light and dust. And somewhere within that vastness, a single golden point, so small it's invisible, our sun drifts quietly, carrying its family of planets along the galactic tide. It's humbling to realize how small we are, yet how intricately connected. Every atom on Earth once danced in that same spiral. Every beam of light that reaches us began its journey within that grand structure. We are, in every sense, shaped by the same forces that sculpted the Milky Way itself: motion, gravity, time, and light. And perhaps that's what makes our galaxy so beautiful. It is not just a collection of stars, it is a story in motion. A story of creation, balance, and endless transformation. A story we are still learning to read, one star at a time. At the heart of the Milky Way lies a mystery so immense, so powerful, and so hidden that for most of human history we had no idea it was there. The galactic center, the very core of our spiral home, is a place unlike any other. It is dense, turbulent, and cloaked in dust. It glows with energy that our eyes cannot see. And at its center, buried deep within a sea of stars, lies an invisible giant, a supermassive black hole known as Sagittarius A. If you could travel toward the center of the galaxy, it would be like moving through layers of increasing chaos. Stars grow more crowded, space becomes more luminous, and the sky around you would turn into a dense field of light. You would see ancient red giants drifting beside newborn blue stars, and massive clouds of gas glowing with infrared brilliance. Every direction would pulse with radiation and motion. Yet, even amid this brilliance, something strange happens. There's a point where light itself seems to vanish. A point from which nothing escapes. That point is Sagittarius A, the dark heart of our galaxy. For decades, scientists suspected something extraordinary lurked there. Early radio telescopes in the mid-20th century detected a powerful signal from the constellation Sagittarius, a source unlike any star or nebula. They called it simply Sagittarius A. But within it was a compact, bright object radiating enormous energy. That became Sagittarius A, the asterisk marking it as something special, something unique. Still, the question remained: what was it? No telescope could see through the thick clouds of gas and dust that veil the galactic center in visible light. It wasn't until the arrival of infrared and radio astronomy that we began to peer through the darkness. And what we found changed our understanding of the universe forever. Over years of patient observation, astronomers tracked the movement of stars orbiting an unseen mass at the galaxy's center. These stars, known as the S-stars, move with incredible speed, tracing tight, elliptical paths around something invisible. One star in particular, S2, became famous. Every 16 years, it completes a full orbit around the hidden object, whipping through space at over 7,000 kilometers per second. That's nearly 3% the speed of light. By calculating its orbit, scientists realized that the object it circles must contain the mass of about 4 million suns, all compressed into a space no larger than our solar system. There was only one thing it could be: a supermassive black hole. Sagittarius A does not blaze with visible light. Instead, it emits faint radio waves and bursts of X-rays as it feeds, occasionally swallowing gas, dust, or even a star that wanders too close. When matter spirals into its grasp, it forms a glowing disk of energy, heating up to millions of degrees before vanishing past the event horizon, the point of no return. To an outside observer, it would look like a dark sphere surrounded by a halo of swirling light, the black hole's shadow. In 2022, humanity finally saw that shadow. The Event Horizon Telescope, a global network of synchronized radio dishes, captured the first-ever image of Sagittarius A. What appeared on our screens was not a single photograph, but the result of years of collaboration, data, and precision. A glowing ring of golden light, distorted by the curvature of spacetime itself. It was proof, at last, of what Einstein's theories had long predicted. At the center of our galaxy lies a well in the fabric of reality, a place where time and space fold into themselves. But Sagittarius A is not just a destroyer, it is also a sculptor. Its immense gravity helps shape the Milky Way's structure, anchoring the motion of billions of stars that orbit around it. It acts like the cosmic weight at the heart of a spinning wheel, keeping the galactic disk balanced as it turns. Even though the black hole itself makes up only a tiny fraction of the galaxy's total mass, its influence extends across tens of thousands of light years. The stars near it move like dancers around an invisible partner, tracing orbits that reveal the shape of spacetime. Some are thrown outward in slingshot trajectories, hurled into interstellar space. Others drift closer, drawn by the irresistible pull, their light bending as they fall. It is a celestial choreography, elegant, violent, and precise. If you could stand somewhere near the edge of this region, perhaps within a few light years of the center, the sky would look nothing like the one we know. It would be crowded with stars shining so bright they would cast shadows. Radiation and energy would fill the air, and time itself would stretch and twist. You would feel the slow drag of gravity tugging at your perception, altering how you experience the flow of seconds. It would be both beautiful and terrifying, a place where the universe bends toward eternity. And yet, despite its darkness, Sagittarius A connects us. It reminds us that we are part of something vast and ancient, something held together by invisible forces. The same gravity that binds the stars of the galactic center also holds the sun in its orbit, and the earth beneath our feet. We are, all of us, bound to that same silent heart. In the end, the Milky Way's hidden core is not just a place of destruction. It is the heart of creation itself. Stars are born, live, and die under its influence. Gas clouds swirl and collide, shaping new generations of light. And from a distance of 26,000 light-years, we orbit quietly around it, tiny passengers on a grand cosmic wheel, circling the darkness that makes our galaxy shine. Imagine standing at the edge of a great ocean, so vast that no horizon could ever reveal its far shore. Now, multiply that sense of distance until your mind can barely hold it. That is what it feels like to measure the Milky Way. 100,000 light-years across. A number so large, it almost loses meaning until you start to understand what it truly represents. A light-year is the distance light travels in 1 year. And light, the fastest thing in the universe, moves at about 300,000 kilometers every second. In 1 second, it circles the Earth more than 7 times. In 1 minute, it could journey from Earth to the Moon. And yet, to cross our galaxy, traveling at the speed of light, it would take 100,000 years. Pause for a moment and let that sink in. If a beam of light left one side of the Milky Way the day humanity first discovered fire, it would still be traveling toward the other side long after our species evolved, built civilizations, explored space, and vanished into time. To cross it as a human traveler, impossible in any lifetime. Even at the speed of the fastest spacecraft ever built, tens of thousands of kilometers per hour, it would take billions of years to traverse the Milky Way's full diameter. The galaxy is not just vast, it is beyond comprehension. From above, our home galaxy would appear as a graceful spiral, its arms unfurling like the petals of a cosmic flower. Within those arms lie the stars we see at night, the Orion Arm, the Perseus Arm, the Sagittarius Arm, all weaving through space, filled with nebulae, clusters, and the building blocks of life. Each spiral arm stretches for tens of thousands of light-years, curving around the central bulge where Sagittarius A resides. Between them lie dark lanes of dust and gas, places where starlight cannot escape, and where new suns are quietly forming. Our sun, with all its planets, sits about 26,000 light-years from the galactic center, roughly 2/3 of the way toward the edge. It takes the solar system about 230 million years to make a single orbit around the Milky Way's core. That means since Earth first formed, our planet has only completed about 20 such orbits around the galaxy. Everything humanity has ever done, every birth, every story, every dream, has taken place during a tiny fraction of one cosmic rotation. The Milky Way's disk, where most of its stars lie, is about 100,000 light-years wide, but only about 1,000 light-years thick in most regions. It's like an immense cosmic pancake thin, yet unimaginably wide. Beyond this disk extends the galactic halo, an invisible sphere of ancient stars and dark matter stretching far beyond what we can see. In truth, if you include that hidden halo, The Milky Way may span up to 1 million light-years across, its influence reaching deep into intergalactic space. And then there are the stars, over 200 billion of them, perhaps more. Each one a sun of its own, with planets, moons, and mysteries. Some are smaller than our sun, glowing faintly red. Others are massive blue giants, burning millions of times brighter. Between them drift nebulae, great clouds of gas and dust, where new stars are born and old ones die, scattering heavy elements into space. Those elements, carbon, oxygen, iron, would one day form the worlds that give rise to life. When we compare the Milky Way to other galaxies, we find it is neither the largest nor the smallest. It is a giant among ordinary spirals, a mid-sized titan in a universe of extremes. Some galaxies, like the small Magellanic Cloud, are mere smudges beside us, dwarfs a few thousand light-years across. Others, like Andromeda, our nearest spiral neighbor, stretch over 220,000 light-years from end to end. And beyond even those are true giants, elliptical galaxies so large they span millions of light-years, containing trillions of stars. Yet size is not everything. What makes the Milky Way special is that it is alive, constantly changing, growing, and nurturing new worlds. Still, most of our galaxy is invisible. The stars we see are only a tiny fraction of its total mass. The rest is made of something we cannot see, dark matter, a mysterious substance that neither emits nor absorbs light, but reveals itself through gravity. Dark matter forms an immense halo that surrounds and stabilizes the Milky Way, preventing its outer stars from flying away. Without it, our galaxy's spiral arms would tear themselves apart long ago. We live inside this unseen framework, bound by forces we can feel but not detect. Now imagine, for a moment, a journey across it. You begin near the galactic center, where stars swarm like fireflies in a storm. You pass through the glowing nebulae of the inner arms, past clusters of newborn suns, and into the quieter outskirts where the stars grow sparse and old. You would travel through clouds of hydrogen gas, through supernova remnants and star-forming nurseries, through the silent dark where only cosmic rays whisper through the void. Each step of the way, you would move through centuries, millennia, and epochs, the scale of your journey measured not in miles, but in ages. By the time you reached the far edge of the Milky Way, 1,000,000 lifetimes would have passed. Civilizations would have risen and fallen. Stars you once saw would have died, their light extinguished before your journey was complete. You would turn back, and the galaxy itself would seem to breathe, a living organism of stars and shadow, spinning slowly in the cosmic dark. And somewhere, hidden within one small arm of this vast spiral, is a tiny blue planet circling an ordinary star. That planet is our home. Our entire history, our dreams, our discoveries, all of it, exists within a minuscule fraction of this immense galactic sea. It humbles us, and yet it connects us. Because even though we occupy just one tiny corner of the Milky Way, we belong to it. Every atom in our bodies was forged from stars that once shone across its arms. We are part of its story, threads of light woven into a cosmic masterpiece 100,000 light-years wide. Beneath the soft glow of night, when you look up at the sky and see a handful of shimmering points, it's easy to forget how immense the Milky Way truly is. Those few thousand stars visible to the naked eye are but a whisper of what lies beyond, an invisible ocean of suns, stretching in every direction, numbering in the hundreds of billions. Astronomers estimate that the Milky Way contains between 200 and 400 billion stars, perhaps even more, depending on how faint and small the dimmest ones are. Each star is a world unto itself, a burning sphere of plasma, shaped by gravity, powered by fusion, and glowing across the depths of space. Yet not all stars are the same. The Milky Way's stellar population is a tapestry of color, age, and energy, a reflection of billions of years of cosmic history written in light. The most common of all are the red dwarfs, tiny, cool stars that burn their fuel with astonishing efficiency. They shine faintly, invisible to the naked eye from Earth, but they make up nearly 3/4 of all stars in our galaxy. They live slow, quiet lives, sometimes lasting trillions of years, far longer than the current age of the universe itself. Around these humble suns, planets may orbit in silence, warmed by a glow that will never fade within any human timeframe. Then there are the yellow stars like our sun, mid-sized, balanced between youth and age, energy and calm. These are the stable furnaces where life as we know it might have the best chance to form. Our sun is one of billions of this type, scattered throughout the spiral arms, weaving a quiet rhythm into the galaxy's grand design. Further up the cosmic hierarchy are the blue giants, massive, hot, and dazzlingly bright. They burn with ferocity, living fast and dying young. Their light can be seen across thousands of light years, painting nearby gas clouds in luminous colors. Yet their brilliance is brief. Within a few million years, an instant in cosmic time, they exhaust their fuel and explode as supernovae, scattering heavy elements into space. These explosions seed the galaxy with the ingredients of planets, oceans, and life itself. In death, the blue giants become the architects of creation. Between the extremes are countless varieties: orange dwarfs, white giants, variable stars, and binary systems where two suns dance endlessly around one another. Some stars orbit in dense clusters, their gravity entwined like ancient partners in a cosmic waltz. Others drift alone in the galactic outskirts, solitary wanderers beneath the eternal dark. The Milky Way stars are not distributed evenly. In the spiral arms, the glowing bands of our galaxy's disk, new stars are constantly being born. These are the stellar nurseries, vast clouds of gas and dust where gravity begins its quiet work. Inside them, the pressure builds, atoms collide, and light ignites. What begins as a whisper of hydrogen becomes a blazing sun. One by one, these newborn stars emerge from their cocoons, lighting up their surroundings like candles in a dark cathedral. The Orion Nebula, visible even through small telescopes, is one such nursery. Just 1,300 light-years away, it offers a glimpse of our galaxy's creative power, hundreds of new stars being born in a single cloud, surrounded by swirling disks of material that may one day form planets. Across the Milky Way, thousands of similar regions exist, each one a cradle of future worlds. Yet not all stars are young. Scattered far above and below the galactic plane are ancient globular clusters, dense, spherical gatherings of hundreds of thousands of stars bound together by gravity. These clusters are among the oldest surviving structures in the galaxy, dating back more than 12 billion years, formed when the Milky Way itself was still young. Their stars are small, dim, and reddish, but they carry the memory of the galaxy's beginnings, the fossils of its stellar past. Each region of the Milky Way tells a different story. Near the center, stars are older and metal-poor, born before heavy elements had spread throughout the galaxy. In the outer arms, stars are younger and richer in those elements, forged from the ashes of previous generations. This variation paints a clear portrait of our galaxy's evolution, from a chaotic cloud of gas in the early universe to the structured, star-filled spiral we inhabit today. Through every supernova, every birth, and every quiet, enduring glow, the Milky Way renews itself. It is not a static structure but a living ecosystem of stars, forming, dying, and being reborn over billions of years. When we gaze at the night sky, we are not merely looking into space. We are looking into time itself, seeing the layers of our galaxy's long and unbroken story. Some of the light that reaches your eyes tonight began its journey thousands of years ago, long before history was written. Some left its star before humans walked the earth, and some, shining faintly at the edge of detection, has traveled for tens of thousands of years, crossing the immense gulf of the Milky Way just to touch this small world for a moment. In that light is the story of the stars, of everything that has ever been and everything that will be. We are surrounded by them, made of them, and one day we will return to them. The stars are not distant. They are our ancestors, our origins, and our future written across the canvas of a galaxy 100,000 light-years wide. In the darkness beyond the Milky Way's glowing arms lies something unseen, an enormous, invisible structure that shapes everything we know, yet reveals itself only through its silent pull. It does not shine, it does not reflect, and it does not interact with light in any way. And yet, without it, the galaxy as we know it could not exist. Astronomers call it the dark matter halo, a vast, spherical envelope of invisible mass that surrounds the Milky Way and holds it together. To understand this strange entity, we must look not with our eyes, but with our instruments and trust in the quiet language of gravity. When scientists measured how fast the stars in the Milky Way orbit the galactic center, they expected something simple. The farther a star is from the center, the slower it should move. This is what happens in our solar system. The outer planets, like Neptune and Pluto, move slowly around the Sun because its gravity weakens with distance. But when astronomers mapped the speeds of stars across the Milky Way, they discovered something astonishing. The stars at the outer edge were moving just as fast as those much closer to the center. That made no sense, unless something unseen was there, exerting extra gravity. The visible matter, stars, gas, dust, wasn't enough to explain it. There had to be an enormous amount of invisible mass, extending far beyond the galaxy's visible boundaries. Thus was born one of the greatest mysteries in modern science, dark matter. We cannot see it, but we can feel its presence in the motion of stars and the bending of light. It acts like a cosmic skeleton, giving galaxies their structure and stability. Without dark matter, the Milky Way's outer regions would drift apart, and the spiral arms would unravel into the void. Instead, they remain intact, bound by the gravitational web of something we cannot touch or detect directly. Imagine, for a moment, the Milky Way as you've seen it in pictures, a flat spiral, luminous and elegant, about 100,000 light-years across. Now imagine that entire disk floating within a gigantic, invisible sphere, the dark halo, stretching nearly 1,000,000 light-years from side to side. That's roughly 10 times wider than the visible galaxy itself. Every star, every planet, every nebula you can see is merely the glowing center of a much larger, unseen structure. This halo is thought to contain 5 to 10 times more mass than all the visible stars and gas combined. In other words, most of the Milky Way, most of our home galaxy, is made of something we cannot see. It is not made of atoms, not of light, not of anything familiar. It passes through ordinary matter as though it weren't there, like a ghost threading through the walls of the universe. And yet, its influence is everywhere. Every orbit, every motion of every star is guided by it. When the Milky Way formed billions of years ago, it was the dark matter halo that provided the gravitational foundation, the invisible well into which gas and dust collapsed, forming the first stars and galaxies. Without dark matter, there might have been no Milky Way at all. Scientists still do not know what dark matter truly is. It might be made of unknown particles that rarely interact with anything. It might be something stranger, a property of space itself, a shadow of gravity, or even a sign that our understanding of physics is incomplete. Experiments deep underground, in mountain tunnels and frozen detectors, continue to search for its elusive traces. So far, dark matter remains hidden, a secret the universe has not yet chosen to reveal. But even without seeing it, we can feel its structure through its effect on light. When light from distant galaxies passes near the Milky Way, it bends ever so slightly, a phenomenon called gravitational lensing. This bending tells us the shape of the unseen halo. It's as if the galaxy were wrapped in a massive, transparent bubble, its gravity distorting the light that passes through it. Picture this invisible sphere surrounding everything we know, extending far beyond the spiral arms, far beyond the last star. encompassing even the dark voids between galaxies. It is not empty. It is a quiet sea of gravity, holding the Milky Way together through eons of cosmic time. Within this invisible shell, stars orbit like fish in a vast, unseen ocean, unaware of the depth that cradles them. And somewhere within that halo, just a few tens of thousands of light years from the center, floats a small yellow star and a blue planet we call home. Our entire existence, our history, our dreams, are unfolding in a tiny corner of a structure so large we can scarcely imagine it. The next time you gaze at the night sky, remember, what you see is only the luminous skin of the Milky Way. Beneath and beyond it lies the hidden body of the galaxy, vast, silent, and unseen, shaping every star's motion, holding every world in place, and reminding us that the greatest forces in the universe are often invisible. The Milky Way's companions, our galaxy, isn't alone in the vastness of space. Like a great celestial monarch, the Milky Way is surrounded by smaller companions, tiny galaxies that orbit it in an intricate cosmic dance. These are the dwarf satellite galaxies, and they number in the dozens, maybe even hundreds. Among them, two stand out like loyal companions glowing softly in the southern skies, the large Magellanic Cloud and the small Magellanic Cloud. The Magellanic Clouds are irregular, twisted little galaxies, not grand spirals like the Milky Way, but warped and scarred by their gravitational encounters with it. They are visible to the naked eye from the southern hemisphere, appearing as faint cloudy smudges against the night. Yet, within those ghostly forms lie billions of stars, vast nebulae, and even regions where new stars are still being born. The Large Magellanic Cloud, LMC, about 160,000 light-years away, is the bigger of the two. It contains the famous Tarantula Nebula, one of the most active star-forming regions in our galactic neighborhood. The Small Magellanic Cloud, SMC, trails behind, at roughly 200,000 light-years, slightly dimmer but equally fascinating. Together, they orbit our galaxy like twin satellites, leaving behind long streams of gas and dust known as the Magellanic Stream, a cosmic tail that wraps partway around the Milky Way, evidence of their gravitational struggle. But these two aren't alone. The Milky Way's outer halo is filled with faint dwarf galaxies, the Sagittarius Dwarf Galaxy, the Draco Dwarf, the Ursa Minor Dwarf, and many more. Most of them are so dim and diffuse that we only discovered them recently, through careful sky surveys and data from missions like Gaia. These faint companions are like whispers in the dark, each one slowly being pulled apart by our galaxy's immense gravity. Over billions of years, they will merge completely into the Milky Way, their stars joining our own. This process of swallowing smaller galaxies is how the Milky Way grew. It's an ongoing cycle of creation and destruction, of merging and renewal. Our galaxy is not static, it's alive, constantly reshaped by the cosmic tides of gravity. The Magellanic Clouds and the dwarf satellites are a reminder of that, smaller siblings orbiting a vast spiral, each interaction a note in the grand symphony of galactic evolution. And beyond them lies an even bigger truth. The Milky Way itself is not the only great power in its region of space. It too belongs to a larger family, the local group, a cluster of about 50 galaxies bound together by gravity. At its heart stand two giants, the Milky Way and Andromeda, slowly moving toward each other on an inevitable collision course. Step outside the borders of our galaxy, and you find yourself in a much larger cosmic community, a gathering of galaxies known as the local group. This is our galactic neighborhood, a family of more than 50 members bound together by gravity, floating through the dark ocean of space. At its heart are three main galaxies: our Milky Way, the majestic Andromeda Galaxy, M31, and the graceful Triangulum Galaxy, M33. These three are the heavyweights, each surrounded by smaller dwarf galaxies like a constellation of tiny moons. Together, they form a gravitationally bound cluster spanning roughly 10 million light-years across. Within this vast expanse, invisible threads of dark matter weave a cosmic web, holding these galaxies in place and shaping their orbits like a silent, unseen conductor guiding a slow cosmic symphony. The Andromeda Galaxy is the Milky Way's most notable neighbor, a stunning spiral roughly the same size as our own, maybe even a little larger. It sits about 2.5 million light-years away, which sounds impossibly distant, but in the vastness of the universe, that's practically next door. Through a telescope, Andromeda appears as a soft, elongated glow, its billions of stars stretching across the void, and in that glow lies our galaxy's future. You see, Andromeda isn't just sitting still. It's moving, racing toward us at about 110 kilometers per second, pulled closer by the same gravitational bond that ties the local group together. In roughly 4 billion years, the Milky Way and Andromeda will collide in one of the most magnificent events in the universe, the birth of a new galaxy. Astronomers call this future cosmic union Milkdromeda, a single, enormous elliptical galaxy formed from the merging of the two spirals. It won't be a violent collision in the way we might imagine. Space between stars is so vast that very few, if any, stars will actually hit one another. Instead, the two galaxies will pass through each other, their shapes distorted by gravity, flinging out streams of stars like tidal waves. Over billions of years, they'll dance closer, swirling and merging into one. The supermassive black holes at their centers, Sagittarius A and the Milky Way and Andromeda's own giant, will spiral together and eventually unite, releasing an immense burst of gravitational waves that will ripple across the cosmos. And even after this grand merger, the story continues. The Triangulum Galaxy, the third major member of the local group, may join in as well, either orbiting the new Milkdromeda or merging with it later on. Eventually, the entire local group will collapse inward under its own gravity, forming a single massive galaxy surrounded by the remnants of its former companions. Beyond the local group lies the Virgo supercluster, and beyond that, the Laniakea supercluster, the enormous structure that contains tens of thousands of galaxies, including ours. But at the scale of the universe, even those clusters are just small ripples in an endless cosmic sea. For now, though, our focus remains here in the quiet suburbs of the cosmos, among our nearest galactic neighbors. The Milky Way, Andromeda, Triangulum, and their many satellites drift together through time, locked in a gravitational embrace that will shape their destinies for billions of years. It's a reminder that nothing in the universe stands still. Even galaxies, these titanic, star-filled islands, are travelers, drawn together in a slow, inevitable ballet of creation and change. And as we gaze at Andromeda through our telescopes tonight, we are, in a sense, looking at our own future, a reflection of what the Milky Way will one day become. The Milky Way is often imagined as a majestic swirl of light, a spiral of billions of stars sweeping gracefully through space. But inside those spirals lies the real story of our galaxy's living structure, a story of birth, motion, and transformation. To understand the Milky Way, we must travel into the arms themselves, where stars are born and the pulse of the galaxy can truly be felt. We live inside one of these arms, in a small region called the Orion Arm, sometimes called the Orion Spur. It's not one of the Milky Way's major arms, more like a smaller branch, a subtle ripple between two great spirals. Our solar system sits quietly here, roughly 27,000 light-years from the galactic center, orbiting within a calm zone surrounded by brilliant stellar nurseries and dark molecular clouds. The Orion Arm stretches for thousands of light-years, home to some of the night sky's most familiar constellations, Orion, Perseus, Cygnus, and to some of the most beautiful star-forming regions we've ever seen, such as the Orion Nebula, where stars ignite from collapsing clouds of gas and dust. But the Orion Arm is just one part of a much larger design. Beyond it lies the Perseus Arm, a grander, more massive structure farther out from the galactic center. This is one of the Milky Way's primary spiral arms, filled with glowing nebulae and massive star clusters. Here, stars blaze with youthful energy, lighting up surrounding gas clouds like cosmic lanterns. Radio observations reveal immense stretches of hydrogen gas tracing the arm's path, forming a luminous trail that wraps around the outer reaches of the galaxy. Moving inward from the Orion arm, we reach the Sagittarius arm, closer to the galactic core. It's another of the Milky Way's major arms, denser, brighter, and teeming with newborn stars. Within it lies the Eagle Nebula, home to the famous Pillars of Creation, and the Lagoon Nebula, vast clouds of dust and hydrogen glowing under the radiation of massive young suns. These arms are where the galaxy breathes, where gas and gravity come together to create stars, planets, and solar systems. Deeper still, even closer to the center, lies the Scutum, Centaurus arm, the most massive and luminous of them all. This colossal structure sweeps around the inner galaxy, spanning tens of thousands of light years. Within it are the galaxy's most powerful star-forming regions, stellar factories producing giants so bright they can be seen across immense distances. Here, the gravitational pull of the galactic bulge begins to dominate, twisting the arm into a graceful curve around the center, where Sagittarius A, our supermassive black hole, resides. The spiral arms themselves aren't solid structures, they're patterns of density, like waves moving through water. Stars, gas, and dust drift in and out of these waves, compressed and stretched by gravity. As material passes through a spiral arm, the increased density triggers star formation, compressing gas clouds until they collapse under their own weight. New stars ignite, shining for millions or even billions of years before drifting onward, leaving the arm behind. The arms are not permanent. They're moving patterns, slowly changing shape over time, sculpted by the gravitational interactions of stars, gas, and dark matter. If we could view the Milky Way from far above, we'd see this slow dance unfolding, four main arms winding outward from the central bulge, intertwined with smaller spurs and filaments, each glowing with clusters of stars and nebulae. We'd see shock waves of light where new stars ignite, and dark lanes of dust casting shadows across the galactic plane. We'd notice that the arms don't stay fixed, they twist and shift, driven by the rotation of the galaxy. The inner regions spin faster than the outer ones, creating a graceful spiral motion that maintains its form over cosmic timescales. Every star, including our Sun, is a traveler on this endless journey. The solar system orbits the galactic center once every 225–250 million years, a single galactic year. During that time, it passes through different arms, moving in and out of regions of star formation. When it crosses an arm, the density of stars, dust, and gas increases, and the night sky would look brighter with distant suns. Then, as it drifts into quieter zones between arms, the skies would darken again, the spiral glow fading into the background. This constant motion gives rise to a living, breathing galaxy. Stars are born, live, and die within the spiral arms, enriching the interstellar medium with heavier elements that seed new generations of stars and planets. Supernova explosions scatter those elements across light years of space, fueling the cycle anew. The arms are, in essence, the arteries of the galaxy, channels through which energy, matter, and creation flow. And as we look out across the Milky Way from our place in the Orion arm, we can see just a tiny glimpse of that vast spiral network. Every glowing patch in the night sky, every hazy cluster or misty band is part of this structure, billions of suns spread across thousands of light years, each one a spark in the grand pattern that defines our galactic home. We often think of the Milky Way as still and serene, but it is anything but static. Its spiral arms twist, its stars migrate, its clouds collapse and explode. It's a vast ecosystem of light and motion, a cosmic city constantly under construction. And we, from our small corner in the Orion Spur, are part of that living structure, orbiting within the ever-changing arms of a galaxy that has been building, reshaping, and renewing itself for more than 13 billion years. To journey through the spiral arms is to watch the Milky Way breathe, a slow, eternal rhythm of creation and transformation, unfolding quietly in the depths of time and space. Life within the Milky Way is not evenly scattered, nor is every world equally blessed with the right ingredients to sustain it. Within this immense, spiral-shaped ocean of stars lies a narrow, delicate region often called the galactic habitable zone, a cosmic balance point where conditions might just be right for life to flourish. It's a concept born from both astronomy and biology, a reminder that even across billions of stars, the right place can make all the difference. The Milky Way spans about 100,000 light-years in diameter, with its center dominated by high-energy radiation, powerful gravitational forces, and dense star fields. The inner regions of the galaxy shimmer with light, millions of stars packed close together, swirling around the massive black hole, Sagittarius A. But beauty here hides danger. The central zones are tumultuous. Frequent supernova explosions, intense gamma-ray bursts, and torrents of cosmic radiation make it difficult for fragile life to survive. Worlds born too close to the core may never find peace, their atmospheres stripped, their surfaces scorched, their oceans boiled away by relentless stellar storms. Farther out near the galactic edge, the opposite problem arises. There, the density of stars and heavy elements drops. Stars become fewer and the space between them widens. These distant regions, though calmer, are poor in the heavier elements, carbon, oxygen, iron, that are essential for forming rocky planets and complex chemistry. Life might find stability there, but it would struggle for the raw materials needed to evolve complexity. Between these extremes lies a golden middle, the galactic habitable zone, roughly 25,000 to 30,000 light-years from the center, and that's exactly where our solar system resides. It's here, in this gentle orbital lane, that the conditions balance, far enough from the chaos of the core, but close enough to the star-rich regions where heavy elements abound. This is the quiet neighborhood of the Milky Way, where stars like our sun can shine for billions of years, undisturbed, giving life a chance to take hold and evolve. Our sun, orbiting calmly in the Orion Arm, may owe its stability and our very existence to this fortunate placement. In a denser region, our world might have been blasted by radiation or disrupted by the gravity of nearby stars. In a sparser zone, there might not have been enough material to form Earth at all. It is as though our planet was born in a cosmic safe zone, shielded from the worst, yet rich enough to nurture the best. Scientists believe that within this same galactic belt, there may be countless other stars hosting planets that share similar conditions. These are often referred to as life-friendly systems, where planets orbit at the right distance from their suns, with liquid water, stable temperatures, and the protective presence of magnetic fields and atmospheres. The discovery of exoplanets in recent decades, worlds like Kepler 452b or TRAPPIST-1e, has strengthened this vision. Many of these planets orbit stars not too different from our own, positioned within the same habitable ring of the Milky Way. Yet, even within this life-sustaining zone, the universe is far from tranquil. Supernovae, the deaths of massive stars, occasionally explode nearby, sending waves of radiation sweeping across light-years of space. A single supernova within 30 light-years could damage a planet's atmosphere, exposing its surface to cosmic rays. Over cosmic timescales, such events have likely shaped life's story on Earth, perhaps even triggering evolutionary shifts. Then there are gamma-ray bursts, the most violent explosions known. Though rare, these cosmic flares can unleash more energy in seconds than our sun emits in its entire lifetime. A close enough burst could sterilize whole regions of a galaxy, erasing eons of evolution in an instant. Fortunately, our solar system's position in the Milky Way's mid-disk shields us from most of these catastrophic events. We orbit in a calm suburb, not a cosmic downtown. Even black holes, though fascinating, pose invisible threats. Aside from the supermassive one anchoring the galactic center, the Milky Way is scattered with smaller, stellar-mass black holes, remnants of ancient stars. They drift silently through space, occasionally capturing or disrupting nearby matter. But the galaxy is vast, and the chances of one wandering dangerously close are vanishingly small, Through all these perils, Earth has endured. Its orbit remains steady, its star constant, and its biosphere resilient. It's a cosmic lottery win that our planet was born not only at the right distance from the Sun, but also in the right region of the galaxy. A region where stability reigns long enough for life to rise, diversify, and look up in wonder. If we imagine the Milky Way as a great cosmic city, then the inner core would be its bustling downtown, bright, noisy, dangerous. The far edges would be its quiet rural outskirts, calm but lacking resources. And our solar system would sit somewhere in the well-balanced middle suburbs, where conditions are just right for life to thrive. This is why the galactic habitable zone matters so much. It's not just a region of space, it's a window of opportunity. In a galaxy of 400 billion stars, countless worlds may exist, but only a fraction will orbit in this life-friendly band. Perhaps, scattered across its length, other civilizations gaze out at the stars as we do now, each wondering whether they too are alone. The Milky Way may be vast beyond comprehension, but within it lies this precious thread, a ring of worlds where chemistry awakens, biology stirs, and consciousness begins to dream. And somewhere along that spiral path, among billions of suns, we found our home, a small blue planet, thriving in the gentle heart of the galaxy's living zone. The Milky Way we see today, elegant, spiraled, and vast, is not a static creation, but a living, evolving being forged through billions of years of cosmic collisions. Every glittering star, every cluster, every whisper of starlight in its arms carries the memory of a turbulent past. To understand our galaxy's story, we must look backward in time, to when the Milky Way was not yet the grand spiral we know, but a growing seed of stars surrounded by chaos. More than 13 billion years ago, in the youth of the universe, the first small galaxies began to form. The Milky Way's earliest ancestors were tiny clouds of gas and dark matter that clumped together under gravity's pull. These proto-galaxies collided and merged again and again, their stars mingling, their gases compressing, birthing new generations of suns. Out of these violent unions, the first outline of what would one day become our Milky Way took shape. Astronomers today can trace this history like detectives at a cosmic crime scene. The clues lie scattered across the sky, stellar streams, faint rivers of stars stretching across vast distances. These streams are the ghosts of ancient galaxies, torn apart by the Milky Way's gravity and stretched into delicate arcs. Each one tells a story of a smaller system that once drifted too close, only to be devoured and absorbed. One of the most famous of these is the Sagittarius dwarf galaxy, a small companion currently being shredded by the Milky Way's pull. Its stars are smeared across the sky, wrapping around our galaxy like strands of silk. In time, its remnants will blend seamlessly into the Milky Way's halo, another chapter added to our galaxy's long record of mergers. But the Sagittarius dwarf is not the first, nor will it be the last. Billions of years ago, the Milky Way collided with another large system in what astronomers call the Gaian-Enceladus event. Evidence of this colossal merger lies hidden in the motions of stars. Using data from the European Space Agency's Gaia mission, scientists have mapped the velocities and compositions of millions of stars, revealing two distinct populations, one native to the Milky Way and one belonging to the galaxy it absorbed. This ancient collision, around 10 billion years ago, reshaped the Milky Way's structure, thickened its disk, and gave birth to the sprawling stellar halo that now surrounds it. Even before that, smaller mergers occurred, each one adding new material, stirring the galactic pot and sparking waves of star formation. These events enriched the galaxy with heavier elements, the kind forged in supernova explosions, spreading iron, carbon, and oxygen, the building blocks of planets and life. The Milky Way became a cosmic melting pot, not just of stars and gas, but of histories. Every cluster, every stellar stream is a fossil of something that once was. In the outer halo, where the light is faint and the stars are old, we find these remnants frozen in time. Some stars orbit on strange, looping paths, unlike those born in the Milky Way's calm, rotating disk. They are the immigrants, survivors from long-lost galaxies that merged and disappeared. Others cluster in groups known as globular clusters, dense spheres of ancient stars that predate much of the galaxy itself. They are among the oldest witnesses to our galaxy's chaotic youth. What's remarkable is that this process has never truly stopped. The Milky Way continues to grow and evolve, consuming its smaller neighbors, pulling them in over millions of years. Even now, the Magellanic Clouds, our nearby dwarf companions, are being drawn ever closer, their gas streams already feeding the Milky Way's outer regions. In time, they too may merge completely, adding new material to our galaxy's spiral arms and triggering fresh waves of star birth. And beyond that, an even grander collision awaits. Roughly 4 billion years from now, our galaxy will meet its equal Andromeda. The two spirals are on a slow-motion collision course, drawn together by mutual gravity. When they finally merge, their stars will weave together into a single, enormous elliptical galaxy, what astronomers sometimes call Milkdromeda. It will be a breathtaking transformation, reshaping both galaxies forever. But collisions in space are not like crashes on Earth. The vast distances between stars mean that few, if any, will actually collide. Instead, gravity will choreograph a spectacular dance. Stars flung into new orbits, nebulae compressed into new generations of suns, and black holes spiraling toward one another at the center. Over billions of years, the chaos will settle into calm, and a new, larger galaxy will emerge, brighter, older, and wiser, carrying the DNA of both its ancestors. When we gaze at the Milky Way in the night sky, we are looking at the product of countless cosmic unions, a survivor of violence and transformation. It's humbling to realize that even our sun and its planets are part of this ongoing story. The atoms that make up our world, our oceans, even our bodies, were forged in the hearts of stars from long-lost galaxies that the Milky Way once absorbed. We are, in a very literal sense, made of galactic memory. The Milky Way's past is written in light and motion, in the silent orbits of ancient stars, in the faint trails of lost companions that encircle it still. It is not a relic but a living record, a galaxy still growing, still consuming, still changing. Every time a smaller galaxy drifts too close, the Milky Way stretches out its gravitational arms, embracing it, adding its stars and history to its own. And so the story continues, not of destruction, but of creation through merger, of unity through collision. The Milky Way we know today is only the latest chapter in a saga that began when the universe was young. It is a galaxy forged in fire and gravity, shaped by chaos, and destined to evolve for billions of years more. Each sunrise on Earth, each star that flickers above us, is a quiet echo of that grand, ongoing act of cosmic becoming, the eternal growth of the galaxy we call home. The Milky Way story, like all cosmic tales, is not one of permanence, but of transformation. Everything in the universe, from the smallest atom to the largest galaxy, moves through an endless cycle of birth, evolution, and quiet decay. Our galaxy is no exception. The Milky Way has lived for more than 13 billion years, and though it still glows with the light of hundreds of billions of stars, its future will unfold on a scale far beyond human imagination. If we could leap forward through time millions, then billions of years, we would witness the slow, graceful unfolding of its fate. The Milky Way, now serene and spiraled, will not remain this way forever. It is destined for a cosmic meeting that will reshape everything we know, a slow, inevitable collision with our neighboring spiral, the Andromeda Galaxy. Even now, Andromeda drifts toward us at about 110 kilometers per second. Across the 2.5 million light-years separating us, this approach is almost imperceptible. But in the vast stillness of the cosmos, that speed is relentless. Over the next 4 billion years, Andromeda will loom larger and brighter in our sky. Its spiral arms becoming visible to the naked eye, first as a faint haze, then as a glowing double spiral. For future beings on Earth, or whatever descendants of humanity exist then, the night sky will become a living canvas of cosmic motion. When the two galaxies finally meet, the encounter will be majestic, not violent. Galaxies are mostly empty space. Stars are so far apart that even during the collision, few will ever touch. Instead, their gravitational fields will intertwine, pulling stars into vast, looping orbits. The spiral arms will stretch and warp, forming long tidal streams that ripple outward like luminous ribbons. Gas clouds will collide and compress, igniting new waves of star formation, a brief renaissance of light before the long fading begins. The Milky Way and Andromeda will pass through each other several times, drawn together by gravity, until their motions settle into unity. Over the course of perhaps 5 to 6 billion years, the two galaxies will merge completely, forming a new and larger structure, what astronomers call an elliptical galaxy. No longer a graceful spiral, this new form will be rounder, smoother, and more diffuse, its elegant arms lost to the slow mixing of billions of stars. Some call this future galaxy Milkdromeda, a poetic blend of both names. It will be immense, far larger than either galaxy alone, containing perhaps 1 trillion stars and an even greater halo of dark matter. At its heart, the two supermassive black holes, Sagittarius A from the Milky Way and Andromeda's central giant, will spiral inward toward one another, losing energy through gravitational waves until they eventually merge. The result will be a single, even more massive black hole, its gravitational pull anchoring the new galaxy's core. For a time, Milkdromeda will shine brightly, its gas clouds stirred into new life, forming clusters of young blue stars. But this burst of creation will not last. Over the next tens of billions of years, the gas will run out. Star formation will slow, then cease entirely. The galaxy will enter a long twilight. The brightest stars will burn out, leaving behind the faint glow of red dwarfs and the cold embers of white dwarfs, remnants of suns that once gave light to worlds. If we move further ahead, past the billion-year marks into the unimaginable trillions of years, we would see the Milky Way transformed beyond recognition. The great spiral that once arched across the night sky will be gone. The merged galaxy will drift in quiet isolation, its starlight dimming as its stars fade and die. The black hole at its center will sit in silence, occasionally devouring the last wandering remnants of gas or unlucky stars that drift too near. The cosmic expansion, driven by dark energy, will continue, stretching space itself. Other galaxies will recede beyond the cosmic horizon, their light forever lost to view. Milkdromeda will become an island in an ever-darkening universe, its light confined to a single patch of sky. For any civilization living then, the cosmos will appear empty, all other galaxies too far away to be seen, all evidence of the wider universe erased by time. And yet, even as the lights go out, something of the Milky Way will endure. Its stars will not vanish all at once. The faintest red dwarfs, those tiny, slow-burning suns that make up most of the galaxy's population, will live for trillions of years, long after every bright star has faded. Around them, planets may still orbit. Some might even hold the last flickers of warmth and life, quiet survivors in a universe grown cold. Eventually, the era of stars will end. The galaxy will fade into a collection of stellar remnants, black dwarfs, neutron stars, and black holes, orbiting invisibly in the darkness. Over unimaginable timescales, gravity will pull these remnants together. Collisions will eject some, merge others, and slowly, the galaxy will collapse into silence. But even then, even when the Milky Way, Andromeda, and all their descendants have faded from sight, the story will not truly end. The atoms that once made up stars, worlds, and beings will remain, scattered through the vast fabric of space. They will drift, eternal and unbound, the dust of a galaxy that once gleamed in the night. It's humbling to think that the shining spiral we see above us, the band of the Milky Way stretching across the darkness, is just one moment in a much longer story. Our galaxy has lived through birth, collision, and renewal, and it will one day dissolve into quiet memory. But for now, we exist within its golden age, a brief window of light between ancient darkness and the silence to come. When we look up at the Milky Way tonight, we are witnessing the living heart of a cosmic being still in its prime, ancient yet young in the span of eternity. Its arms cradle our world, its stars shape our destiny, and its slow, graceful evolution reminds us that nothing in the universe truly ends. It only changes form, glowing softly for as long as the stars remember to shine. There comes a moment, after the long journey through the structure of the Milky Way, after tracing its spiral arms, its hidden halo, its ancient collisions and far future fate, when we must simply pause and reflect. For in understanding our galaxy, we are not merely learning about distant stars and cold physics. We are, in truth, learning about ourselves, about where we come from, what sustains us, and where we ultimately belong. When you stand beneath a dark sky, far from city lights, and look up, what you see, that hazy river of light crossing the heavens, is the combined glow of hundreds of billions of stars, each one a sun in its own right. That pale arch, the Milky Way, is our home viewed from within. We live inside its spiral arms, orbiting quietly, one small world among countless others. The light that reaches your eyes began its journey thousands of years ago, and yet, in that instant, you are connected directly to the galaxy itself. From that perspective, everything changes. The concerns of daily life, the noise, the haste, the endless urgency, all fall away in the face of something so vast, so ancient, and so silent. The Milky Way stretches 100,000 light-years across, yet even that is just one galaxy among perhaps 2 trillion more scattered across the observable universe. And each one, like ours, is filled with worlds, clouds, stars, and mysteries beyond counting. But though the scale humbles us, it does not diminish us. If anything, it ennobles us. For out of all that cosmic dust and starlight, something has emerged that can look back, that can think, feel wonder, and ask questions about its own origins. The same atoms forged in ancient stars now form our blood, our bones, our breath. We are not separate from the Milky Way, we are made of it. We are literally starlight, awakened and aware. Our sun is but one of many, an ordinary star in the Orion Arm, orbiting the galactic center every 230 million years. Yet from this unremarkable corner of the cosmos, life arose, learned to dream, and began to reach back toward the stars. In that sense, the Milky Way is not just our address in space. It is the womb of consciousness itself. Every idea, every heartbeat, every moment of love or discovery, all of it has unfolded under the soft glow of its spiral arms. When astronomers measure distances in light years, they are not just mapping space, they are measuring time itself. The light we see from distant stars is ancient, carrying with it the history of what once was. Every time we gaze into the night, we look into the past, and, in doing so, glimpse eternity. Perhaps that's why the stars move us so deeply. They remind us of how brief our existence is, and yet how intimately we are part of something endless. Think of the generations before us who looked up at that same Milky Way, the early humans who painted stars onto cave ceilings, the philosophers who imagined crystal spheres, the astronomers who charted its shape through telescopes. None of them could touch the stars, and yet each felt drawn to them. Across millennia, the galaxy has been our silent companion, watching civilizations rise and fall, guiding travelers and dreamers alike. And when we finally sent our machines beyond Earth, Voyager, Pioneer, New Horizons, we imprinted them with messages, golden plaques and records that carry our story into the vastness. Somewhere in the distant future, perhaps billions of years from now, long after our sun has faded, those tiny messengers will still be drifting through the Milky Way, carrying whispers of a species that once looked up in wonder and dared to ask who they were. It is humbling to realize that we are both fleeting and eternal, a single spark in the grand sweep of time, yet also part of a cosmic continuity that began before the Earth existed and will continue long after we are gone. The stars we see tonight are not just points of light. They are reminders that creation is still unfolding, that even in a universe tending toward entropy, beauty persists. The Milky Way is, in many ways, a reflection of life itself, luminous, dynamic, full of birth and decay, of order and chaos. Every star's death gives rise to new beginnings. Every collision and merger reshapes the whole. The same cycle of creation and renewal plays out in us, in our growth, our loss, our rediscovery of meaning. So as we conclude this journey through the galaxy, let it not end in distance or data, but in reverence. For when we say the Milky Way, we are not speaking of something far away. We are speaking of our cosmic body, the grand organism of which we are a part. To know it is to know ourselves, fragile, luminous, and woven into the very fabric of the stars. And so, when you next step outside on a clear night, let yourself simply look up. Feel the silence. Let the weight of distance and time wash over you, and then remember, everything you see and everything you are is part of that glowing river above. The Milky Way is not just our galaxy. It is our story, written in light. A story that began in the heart of stars, that found voice in us, and that will echo softly, eternally, through the dark, waiting universe. Don't forget to subscribe for more scientific facts.